My name is Steve Orloff. I'm a farm advisor with the University of California Cooperative Extension, and I'm located up in Siskiyou County, which is one of the northernmost counties in the state, up on the California-Oregon border. And I'll be talking about perennial forage production with limited water supplies, especially thinking about what growers can do in a year like this year where we're faced with drought conditions. And it'll both be consequences of limited irrigation, and then I'll have some recommendations on what farmers should do in a drought year such as this. Oftentimes we're asked to give presentations in Cooperative Extension, and this is an example of a presentation that former irrigation specialist Blaine Hansen and myself were asked to do. We were supposed to talk about double your yield with half the water. Is that possible? And I need to be frank here, I don't think that is possible. There is no silver bullet. When you reduce the water applied to most crops significantly, you will have a significant yield reduction. And the reason for that is, I think most people recognize what this slide represents. Those are the stomates or stomata that are primarily on the underside of leaves. And those stomates remain open during the daytime. And through those stomates, oxygen is expelled and CO2 is taken up. So when the guard cells that control that opening for the stomata are closed due to a lower turgor pressure or drought conditions, you reduce the exchange of these gases and thereby reduce yield. So one of the main questions is, what are the main roles for water in plants? One of the main roles is actually to cool the plant. As the water evaporates from those leaf pores, there's cooling, evaporative cooling that keeps the plant from overheating. Nutrient uptake is another very important role for water in plants. Many of the nutrients are taken up in the transpiration stream, and the nutrients are taken up from the soil and move through the plant. And then also water is necessary for numerous other plant processes as well. Drought is really nothing new to California. We've experienced periodic droughts a number of years. This is a slide taken from the refuge in Tule Lake in 2001, and this is the year that all irrigation water was withdrawn for most of the season in the Klamath Basin, Tule Lake area. This photograph here is a photograph of the Scott River. Periodically in drought years, the river dries up later on in the season. So drought is nothing new to California. This is something that we deal with in different years. So as a farm advisor, we're frequently asked questions by growers, and especially in a drought year like this, we're asked questions about what they can do in a water short year. One of the questions is, what will happen with my forage crops with reduced irrigation water this year? Specifically, what will be the impact on yields this year? And then also, longer term, what is the effect on stand persistence and future production for that perennial forage crop? Second question is, what is the best strategy to maximize production? Given that in a year like this, many growers won't have water or will just have water partway through the season, the question is, are you best off to irrigate in the spring as long as the water lasts, or is the better option to hold water back and deficit irrigate in the spring and then to continue irrigate but at a lower level for as long as you can through the year? Two different strategies to consider. Another question is, are there alternative forage crops or management practices that growers should consider in a drought year compared to a normal year? The first crop that I'll be talking about is alfalfa. Alfalfa is an important crop in the Intermountain area. It's one of our main crops that's grown there. And alfalfa is actually better adapted to drought conditions than most of the other crops that we grow in California. As a deep-rooted perennial crop, alfalfa can survive drought periods of deficit irrigation. If you compare that with other crops, in this slide here it shows potatoes, but it could be potatoes or onions, tomatoes, a number of different tree crops. If the water is withdrawn partway through the season, then the result is there is no marketable yield at all. That's different with alfalfa. Yield will be reduced, but there still will be some marketable yield. And I'll show some results that we've had from trials in the Intermountain area. Similar research has been conducted in other areas of California with alfalfa. So this just gives a brief rundown of the studies that we've conducted over the years. It's been multiple years. We looked at, first off, normal full season irrigation, standard grower practice in a year where there's ample water. The next comparison is where the last irrigation occurred before the first cutting. So that last irrigation would typically be June 1st or a little bit earlier because our first cutting in that area is typically sometime in that first or second week of June. Then the third treatment there is the last irrigation occurred before second cutting. So our second cutting is ordinarily toward the end of July, so the last irrigation would be around July 15th if we had that cutoff. We tried this experiment in a number of different locations. Some of the sites were in Malin, Oregon. Soil type there is a fine sandy loam. We also conducted trials in Tule Lake, a heavier soil type with a higher organic matter content, and it's a capjack silt loam type of soil. Then we also, in another valley in the Intermountain area, we conducted trials as well. That was in Scott Valley, a lighter textured soil, and that was a loam or a sandy loam soil. This is the typical setup that we used for most of these trials. The fields were sprinkler irrigated with a wheel line system, and we simply plugged off consecutive nozzles, 3 or 4 nozzles in a row, and monitored yield and the impact of an early irrigation termination in those areas. This photograph shows typically what the fields look like after we ceased irrigation. In the foreground is where we had the early irrigation cutoff, and then in the background, past the yellow line that goes across the slide, that was full irrigation. So you can see a fairly dramatic drop-off in production after we initiated our drought irrigation treatments. Sometimes the results were pretty dramatic, especially as you progress through the year. You can see in the foreground an early irrigation cutoff compared to full irrigation in the back, and a very striking difference in alfalfa growth. This slide here shows the results. On the y-axis, the vertical axis, is the tons per acre that we had. Then along the bottom are the location or the year. So for example, this here was Malin, sandy loam soil in 2003, Tule Lake silt loam 2003, and so on along the x-axis. So what this slide shows is the actual yield reduction that occurred from early irrigation termination. So this is the yield reduction compared to what the yield would have been with full irrigation. So in the first example here on a Malin sandy loam, the yield was reduced 0.6 tons. If we had no irrigation after first cutting, and the yield reduction was less, 0.29 tons, if we had no irrigation after second cutting. These sites here, Tule Lake, and Tule Lake, those are all the same soil type, just different years. You can see very consistent, a 0.71 ton yield decrease if we didn't irrigate after first cutting, and yield decrease a little bit less, 0.53 tons if we didn't irrigate after second cutting. So those were all Tule Lake sites right there on a heavier organic clay loam soil. In Malin, Oregon, a sandy loam site, you can see we lost a ton and a half when we didn't irrigate after first cutting, and 3/4 of a ton when we didn't irrigate after second cutting. Very similar in Scott Valley, very similar yield decreases. Then on a lighter soil texture, a sandy loam site in Scott Valley, the yield decreased 2.2 tons if we didn't irrigate after first cutting, and 1.25 tons if we didn't irrigate after second cutting. So average across all those sites, we had a 1.1 ton yield decrease with no irrigation after first cutting, and a 0.62 ton yield decrease with no irrigation after second cutting. I need to point out we really need to look at it in terms of a practical yield reduction, because in these plots we're harvesting all the forage that grew. But in a real grower situation, if the yield is less than half a ton, it's typically not worth harvesting costs, so growers would not make hay on such a low yielding field such as that. So in the practical yield reduction, excluding the cuttings that were less than half a ton, here's the yield reduction that occurred. Some sites you can see fairly large, 1.84 yield reduction if it wasn't irrigated after first, and 3/4 on second, and so on. Our highest yield decrease was on the lighter textured soil in Scott Valley, and the yield decreased 2.82 tons if a field couldn't be irrigated after first cutting, and approximately 1.5 tons if it couldn't be irrigated after second cutting. So on average, the yield decrease with a cutoff after first cutting is 1.3 tons, and 3/4 of a ton if it couldn't be irrigated after second cutting. Really want to underscore here the difference in soil type. You can see some fields suffered a fairly significant yield loss where others didn't, and that's largely due to soil type. So if you look at this practical yield reduction, the practical yield reduction and the total yield reduction was the same at the Tule Lake sites, because even when irrigation was cut off, there was still more than half a ton to harvest at each cutting. So one of the points I want to emphasize here is that with deficit irrigation, alfalfa yields are reduced, but there still is something to harvest. And the degree of that reduction depends largely, it's field specific, and depends largely on the soil type in that field. When you start to withdraw the water, you see some dramatic differences in growth, primarily due to site differences and variability in the field. And it's amazing that how some areas will grow normally where other grower areas won't. And we see some plants that are completely stunted with almost no growth. So the real question is that growers frequently ask is, yes, yield will be reduced that year, but that we withdraw the irrigation water, but what are the long-term effects of deficit irrigation? So we came back the year after we imposed these treatments, and we saw there were no visual differences in stand. We took ratings and we counted the number of stems. So there was no visual differences that subsequent year due to our irrigation cutoffs the prior year. The first harvest year yields were identical whether we had deficit irrigation the year before or if it was fully irrigated the year before. These conditions are for the Intermountain area. It can be different in some other sites, especially in extremely sandy sites in the low desert, or sometimes in the low desert also on very heavy cracking soils. So basically in the Intermountain area we saw really no residual effects from deficit irrigation treatments on the yield the subsequent year. Question people often ask then, if you have limited water supply, when should you use that water? When should you irrigate alfalfa? Are you better off to water at the beginning of the season, or again hold back some of that water and deficit irrigate for much of the year? So what's good to look at there is to consider the seasonal yield pattern for alfalfa. In the Intermountain area, we typically have 3 or 4 alfalfa cuttings per year. So what this slide represents is the total of the annual production in percentage. What percentage occurs on the first cutting versus second cutting versus third cutting. So what I'd like to point out here is we have approximately 75% of our annual production already occurs by early July with just our first 2 cuttings. So as I mentioned, sometimes a 4-cut schedule is used, and it's a similar trend again. Our first cuttings are higher yielding than our midsummer cutting or end of the year cutting. So when you have limited water, you're better off to irrigate the beginning of the season rather than try to make that water extend and last through the duration of the season. This slide is actually from the Central Valley, and it shows the water use pattern for alfalfa for the year. The main points to observe here is that water use is less in the early springtime period, peaks out in the middle of summer around mid-July, and then declines again at the end of the year. So what's most important to look at though is the water use efficiency, or how much water you're getting, or excuse me, how much yield you're getting per unit of water. So you can see here we're getting our maximum water use efficiency during this springtime period because we have higher yield at that time period and lower water use. So we're getting what's often referred to as more crop per drop, or you're maximizing the benefit that you get per unit of applied water. So what I'd like to emphasize here then again is the importance of irrigating fully early in the season and then letting the alfalfa go into a drought-induced dormancy state. One question is, in these trials that we conducted, we did not observe stand loss in any of the fields. But does that definitively mean that there can't be stand loss? I don't believe that's the case. Here's a slide that I actually got from a grower that I'm working with. He sent me the slide on the photograph from his cellular phone. And you can see there are areas in this field that are not growing back. And this was because it was a younger stand, and he had 2 years back-to-back of deficit irrigation because he didn't have water to make it through the season. What actually occurred was in the denser areas where the stand didn't have a chance to get as well developed, that's where we saw higher alfalfa mortality. In the thinner areas of the field where the alfalfa was fully developed, it was able to withstand the drought. So I believe that yes, alfalfa is a very drought-tolerant species. It can go into a drought-induced dormancy, but in some situations, especially in a younger stand where the plants are not fully developed, we still can have stand loss with alfalfa as well. As I mentioned, our area produces a lot of alfalfa, and also irrigated pasture is important. Both irrigated pasture, that's for grazing cows, and also for hay crops. So the question is, do these same principles apply for grasses as well as they did for alfalfa? So we conducted a multiple-year study at the Intermountain Research and Extension Center in Tule Lake. Again, the soil there is an organic clay loam soil classified as a mucky, silty loam. And we had numerous different pasture species that we seeded and expose them to deficit irrigation treatments. So it was basically a split plot design where the main plot was our irrigation treatment, and then we had subplots that were 26 different types of grasses. So similar to the alfalfa study, we had an early June cutoff, June 1st cutoff, July 15th irrigation cutoff, or full irrigation throughout the in-season. We had, as I mentioned, 26 different grasses. 10 of those grasses were tall fescue, 7 orchard grasses. Those are the 2 dominant grass types that we have in the Intermountain area. 4 different brome species, 3 different wheat grasses, a fesculolium, harding grass, and a harding grass variety. And then these irrigation treatments, the 3 treatments that I talked about, same as the ones for alfalfa, they were imposed for 3 consecutive years. The corner, this photograph here in the corner, obviously that's not grass, but that is alfalfa, but this is the same irrigation treatment or setup that we use for our irrigation studies with pasture grasses. So these are the results. What happened then when we start to withdraw irrigation water for the grasses? So this is the effect of the irrigation treatments and the different species on our yield with second cutting. And so the second cutting occurred later in July, and the irrigation was withdrawn on June 1st, the 15th, or the green bar is full irrigation. So one of the main things to see right away is with the full irrigation, we had our highest yield with orchard grass, tall fescue, and wheatgrass. What's real interesting to note here, though, it's different than with alfalfa. With alfalfa, after we withdrew irrigation, we still had a fair amount of alfalfa growth and harvestable yield. But you can see here that the brown bars, where the alfalfa was withdrawn after first irrigation, for all the different grasses, we have very, very low yield. Almost all of them were less than half a ton. So grasses just don't tolerate deficit irrigation nearly as well as alfalfa does, and growth pretty much starts to cease as soon as the irrigation water is withdrawn. This slide here shows the effect of irrigation treatments and species on the total yield for that year 2006, the first year of the study. So again, our highest producing grasses were tall fescue, orchard grass, and wheatgrass. You can see the grasses did differ, though, on how much yield was reduced or the degree that deficit irrigation affected total seasonal yield. You can see here orchard grass in the center. It was a very high yielding species when fully irrigated, but notice the degree to which yield dropped with each reduction in irrigation water. And you can see here intermediate wheatgrass, a much more drought tolerant species, was not nearly as affected as was orchard grass by deficit irrigation. Tall fescue here, you can see a gradual stair step down, but it wasn't affected to the same degree as was orchard grass. And here, the last one here, smooth brome, lower yielding to begin with, but here again wasn't as affected by deficit irrigation as was orchard grass. The reduction in yield was not to the same degree. This is the effect then on what those deficit irrigation treatments had on yield the year after, that first cutting yield the year after these different deficit irrigation treatments were imposed. So it's real interesting to note here, intermediate wheatgrass, which is a drought-tolerant species, often grown in dryland situations, that first cutting yield was actually higher when we had our earlier irrigation cutoff and then a gradual step down after that. Interesting, orchard grass, the deficit irrigated plot yielded higher that first cutting and then less for the other. Look how tall fescue performed differently. First cutting yield was the highest when the field was fully irrigated the year before. So we're seeing the carryover effect of a single year of deficit irrigation on the first cutting yield the next year. This slide shows the cumulative yield for the entire duration of the study, years 2006, 2007, and 2008. So here again with full irrigation, tall fescue and orchard grass were the highest yielding species, but look at how much orchard grass yield was reduced over the duration of the trial with deficit irrigation, a real dramatic decrease. Smooth brome, not as high yielding variety in general, but it wasn't nearly as affected as was orchard grass by early season irrigation termination. Probably the most drought tolerant species that we had in the trial was intermediate wheatgrass, and it's interesting here that with full irrigation, intermediate wheatgrass actually yielded less than it did with partial season irrigation. You can see our highest yield occurred with a mid-season cutoff, with the cutoff after first cutting not being too much lower. So the take-home message here really is that not all grass species are equal. Some are much better adapted to drought conditions than others are. And our goal in this trial was to be able to identify a grass species that would yield well with full season irrigation when we had adequate water, and then one that would still survive and persist and yield reasonably well in a year when we only had sufficient water for partial irrigation. This slide shows the effect of the different irrigation treatments on stand density after the trial was completed after 3 years of deficit irrigation. So here's where water was withdrawn prior to the first cutting on the 1st. Here's where water was withdrawn around July 15th, and this last one is with normal irrigation. So you can see with these two species, Lincoln smooth brome and fawn tall fescue, the stand really was not affected too much by the deficit irrigation treatments, and even a slight trend for improved stand with an early irrigation cutoff. Here's another grass species that performed completely differently. This is the most drought-tolerant species, the Oahe intermediate wheatgrass. Under normal full irrigation, we had our poorest stand. The stand did not tolerate full irrigation, and the stand was actually better with our partial irrigation treatments. Here's another one. This line here represents Extend orchard grass, and orchard grass, our best stands were either at full season irrigation or with a mid-season termination, and if we didn't irrigate for the full season, we lost stand with orchard grass, a species that's not nearly as drought tolerant as some of the others that we included in the trial. This is the effect of a number of deficit irrigation on a number of different orchard grass varieties, and you can see the general trend for all of them is the same. Our stand was the best with normal full season irrigation, and then a gradual significant decline with deficit irrigation. There again, because orchard grass is not as drought tolerant as were some of the other species that we considered. Here's the same type of slide showing the effect of deficit irrigation on stand persistence of tall fescue. You can see two distinct groups here. Here's two lower ones that had fairly poor stand after the conclusion of the trial, and a group here where they all look very similar. So you can see in these tall fescue varieties, all the varieties seem to persist fairly well with deficit irrigation. It's interesting to note here with these two varieties, we had the best stand where we actually had an early irrigation season cutoff, and with normal irrigation, we had a reduced stand. And these two varieties are distinctly different than the other group. The reason for this is that these two varieties are a different type, and those varieties are actually a summer dormant type. So the summer dormant types didn't do well with full irrigation for the entire season, but when irrigation was cut off early, they did better. But still, this group up here seems better adapted to our growing conditions in the Intermountain area. So you don't need to consider just the species, but you should also consider the variety as well and its performance under drought irrigation conditions. So when I share this data with growers, they're often wondering, well, does this mean that their pastures will survive fine this year or in another drought year with no irrigation or little to no irrigation for the duration of the season? The short answer to that is no, and the reasons for that is many pastures throughout California are a mix of different species. Perennial ryegrass is another species that's often used in irrigated pastures. It's one that I would not recommend, especially in drought years or under deficit irrigation conditions, because perennial ryegrass is extremely drought sensitive, much more than the other species we included in this trial. Also, many pastures are a mixture of orchard grass and other grasses, and the orchard grass will not persist well in those situations. The tall fescue stands persisted very well in our Tule Lake trials, but it may be different than the actual field conditions that you experience in your field. In this trial, we irrigated all the plots up until June. The drought is so severe this year and in some years that many pasture producers may not have water for the entire season. So without water for the entire season, I'm convinced that we would lose some tall fescue stands. Also, the soils in Tule Lake are deep organic clay loam soils. The tall fescue would not likely persist as well on more gravelly soils or soil with a lower water holding capacity. And lastly, Tule Lake has a water table around, depending on the year, but 4 or 5 feet down. So soils that don't have that high water table, the pasture plants likely wouldn't do as well. So under many conditions, I believe that even tall fescue stands will thin, especially if there's no irrigation water available for the entire year. The other issue is most pastures that are grazed, they also have a clover component, typically white clover. And in a drought year like this, with partial season irrigation or no irrigation, they will likely lose the clover. The clover just won't persist because it lacks drought tolerance. So some recommendations that I'd like to give producers to consider in a drought year such as this. One of the first things is you want to protect the plant crowns. Avoid grazing below a 3-inch stubble height, or higher than that may even be better. Typically in a drought year, growers are hard pressed to find forage to feed the cattle and may want to graze the field down as close to soil level to maximize what they can obtain from a pasture. But this is a bad idea and will affect the recovery of the grasses in the future. What you may wish to consider is to designate a sacrifice area. So an area where you'll go ahead and leave the cows for a longer time period so you have a place to keep them and possibly feed them, knowing that you'll have to reseed that smaller area after the drought is over. It's also important to know the pasture plants or the species that you have in your field and prioritize fields that you think that can withstand the drought conditions because of the species that they have in there. For example, if you have a species, if you have a pasture that is primarily a susceptible plant species, then you may be better off just to forego irrigation on that field, knowing that you will likely need to replant in the future, and concentrate your water on a tall fescue field and let a susceptible species like ryegrass go. Another important thing to consider is fertilization practices. I'd strongly recommend to soil sample to know what the nutrient status is in the field. Fall fertilization is very important in a pasture, especially in a drought year. Fall is the time period when roots are initiated. They're initiated in the fall, less root growth over the winter time period, or almost none, and then they start to grow again in the spring, and then less root growth over the summer. So fall fertilization is important to maximize root growth for the future productivity of those grasses. So phosphorus is known to be very important for root development. So if you soil test your field, find that it's deficient in phosphorus, fall is the best time to fertilize. You'll likely need to reduce the total amount of nitrogen fertilizer you put on or apply because you won't get the same production in a drought year that you would ordinarily. It's also important you don't want to put on a high rate of nitrogen, then have the field become moisture stressed, because you can have a problem with high nitrates and nitrate poisoning in livestock. So that's something to consider, and the hay should be tested to make sure that you're not high in nitrate levels. Also, I would encourage growers to employ rotational grazing, which would allow a longer recovery period for the grasses and to help ensure that 3-inch stubble height or higher. One of the main questions is, if you have enough water up until first cutting, then make a cutting or graze it at that time. Should you irrigate after that or let the plants grow dormant? Some studies have been done by Steve Franson in Washington State University that I'll be showing in a second that are with Timothy rather than some of the other pasture grasses we have. But in that study, he found that regrowth from irrigation after cutting will mobilize the stored fructans or the sugars, and that will weaken the plant for the future. This was a Timothy drought study that he conducted, and the dry is where it was irrigated up until first cutting, and then irrigation was completely withdrawn. The 1X is where it received 1 irrigation after first cutting. 2X is where it received 2 irrigations after first cutting. And you can see here in the dry treatment, the percent survival was the highest, around 69%, and dropped off when the field was partially irrigated or had 1 or 2 irrigations after that time period. So at least with Timothy, the evidence is that you're better off to just cut and let the field go dormant, whereas if you irrigate, it will stimulate new growth and it will deplete the fructans that are stored in that grass stubble that are real important for future growth. So more research needs to be done on some of the other species, and especially for some of our irrigation pastures, to know the best drought strategy for some of these species. Another option that growers may want to consider is perhaps planting some annual grasses that they could be used in a drought year to supplement the feed on the perennial grasses. Triticale is one of the annual species, cereal species that we've worked with. The program that we're looking at is seeding in late August or early September. Irrigate if we have water. If we don't have water, then you could delay to a later timing and not graze in the fall, but you could plant in November. So the intent here was we planted in August, early September. We were able to graze then around October, November time period. Similar program to what they use in the Midwest, where they'll often graze their cereals and then get a grain crop after that. So in this example, we planted late August, early September, grazed, let it recover over the wintertime, grazed again in the spring, and then produced a hay crop after that. So here's an example just of the hay crop that we produced after this field had already been grazed twice, once in the fall and once in the spring. This slide shows the yield levels that we have. Realize it's difficult to see all the treatments we had across the bottom here. We had a number of different species, Triticale, which is the Trit 102, and another variety, Trit 2700. We had wheat and we had rye. Barley. The barley didn't perform as well this year because we had a foliar disease issue that just affected the barley. The main point that I wanted to bring out here, though, is how well Triticale did, and especially what the total yield was when we were grazed in the fall, and then grazed in the spring, and then our hay crop afterwards. So the main message here is by using an annual cropping system like this, we can increase significantly over what we might get from a perennial pasture. So having some annual pastures as well just may increase the flexibility, especially in drought years. But you would have had to have the foresight to plant a crop like this back in the fall. So some final recommendations and conclusions regarding pasture production or alfalfa production in drought years is that alfalfa is definitely well adapted to drought and deficit irrigation, more so than a lot of the other pasture species or the other crops. Yield is affected somewhat, but it still produces water after irrigation ceases. The degree to which it is affected depends primarily on the environment, the weather conditions, and especially on the soil type and the presence or absence of a water table, perched water table. Lastly, the alfalfa in our trials did fully recover, and there was no yield or stand loss after a single season of deficit irrigation. What the future might bring as far as forage crops for deficit situations, drought situations, that I'm sure we will be seeing more of these in the future. One is genetically engineered drought-tolerant alfalfa. That is under development now. When that will be released, we don't know. Also, bloat-resistant alfalfa. So we may have alfalfa that livestock producers can graze directly without the hazard of bloat occurring with the livestock. With limited irrigation water, again, it's best to fully irrigate the first crop. You have higher yield and water use efficiency in that springtime, so when water is available, make sure you irrigate well for that first and or second cutting and then cease irrigating. That's because there's higher yield, and the quality and price are also typically best in that springtime period compared to midsummer. Early season irrigation water is not lost. It will be there for the plants to use later on in the season as long as you're not over-irrigating and driving water down below the root system. Alfalfa is most sensitive to water stress right after a cutting. So if you are going to stress the crop, avoid stressing it right when the regrowth buds are starting to elongate after a cutting. It does less damage if you stress it closer to the cutting time period. Grasses, as I mentioned, are not nearly as drought tolerant as alfalfa. After we quit irrigating or ceased irrigation for the season, there was practically no yield in the following cutting after irrigation ceased. The grasses that are best adapted to deficit irrigation were smooth brome, intermediate wheatgrass, and tall fescue. The wheatgrass was well adapted to deficit irrigation, but it did not tolerate full irrigation because it's more of a drought-tolerant species. The effective irrigation cutoff on stand persistence really depended on the species and somewhat on the variety as well. Orchard grass was most affected by deficit irrigation, and the stand diminished if we couldn't irrigate the full season. And I think our best overall species that produce well for conditions where we had adequate water and for deficit irrigation appeared to be tall fescue. And this appears to be in agreement with the literature from studies that have been done in other areas. If you have a thin alfalfa stand, especially in a drought year, you may want to consider interseeding a cereal crop into that depleted stand, but that would need to be done when the alfalfa is initially breaking dormancy. That would be in February, March, depending on the area. Do not overgraze drought-affected pastures trying to get every last bit of forage. You want to make sure you maintain at least 3 inches of stubble height, because that stubble height is important because that provides the sugar reserves for future growth. Fertilize for maximum production, but watch out for nitrate if you think the water may be cut short prior to a cutting, and test the forage for nitrate. Consider planting an annual crop, annual cereal crops such as triticale, because they have high water use efficiency, and you can typically get the same yield with approximately half the amount of water. But again, you would have to know that you're going into a drought year and plant those species in time. And lastly, pray for rain or snow and at least a quote-unquote normal year next year. That's the best that we can do. Anyway, I thank you very much, and I hope you've enjoyed this presentation.